Hello, my name is Jawed Al-Akbarli and my serial is 10354. Today I'm going to explain the calculus 1 hard problem that I have. My function is integral of x squared plus b over x squared plus 1 times the arctangent of x dx. So this is the function that we have. We'll just simplify it and we'll just make it we'll just put it in the numerator and that's it. The first step that we'll do is simplify. So we have this function and we'll simplify in this way so that in the next steps it will be easier to solve. So we're doing the integral of b minus a times the arctangent of x over x squared plus 1 plus a times the arctangent of x dx. So as you can see in the next step, we're just basically separating these two parts and doing two integrals for each of them. So by writing it like this, in the next step we'll put this into here because we can do it. Why not, to make it simpler? As you can see, b minus a times the integral of arctangent of x over x squared plus b x squared plus 1 dx plus a times the integral of arctangent of x dx. So the second step that we'll do is to find this part first. So this, and we'll use the u substitution method. So if we say that u equals to arctangent of x and also du dx will be equal to 1 over x squared plus 1, this will actually help us. So how did we find it? It's because if arctangent is tangent to the power of -1, it will be tangent of f of x equals to x. So if we differentiate both sides, we'll find that x will be equal to 1 and tangent will be equal to secant squared. And as you can see, f of x does not change, so we cannot change it. But because we're taking the derivative of this, we also have dy dx. So what we find is that dy dx will be equal to 1 over secant squared times secant squared of arctangent of x. So also we know that secant squared equals to tangent squared plus 1. So by substituting it here, we find this. And our result is this. Now, as you can see, we have found x squared plus 1. Now, if you wonder why we're coming back here, and we know that tangent of f of x equals to x, but here we have tangent squared. So if we square this, x will be squared as well. So it will be x squared plus 1, where 1 is here. So what we'll do here is we'll rewrite it in this way so that dx will be equal to x squared plus 1 du, and basically following this we'll find that it will be equal to integral of u du, because you can check it like here, you can check it here and we'll understand why this happened. So what we'll do here is we'll get rid of the integral, and we'll find that it will be u squared plus over 2. And as we know that u equals to arctangent of x, so it will be arctangent squared of x over 2. So the next step will be to do this, and we have a formula actually to solve it. So it will be this formula. So where f will be equal to arctangent of x and g prime will be equal to 1. So the derivative of f will be this, because we already found this in the previous slide, and the integral of g to the prime will be x. So putting it into the function, we'll find this. And now we'll solve for this part because we want to get rid of the integral. So to do this, we'll just again use the u substitution method, where u will be equal to x squared plus 1 and du dx will be equal to 2x, and we can rewrite it so that it will be dx equal to 1 over 2x du. So the answer will be 1 over 2 times the integral of 1 over u du. So as we can see, we have another integral, so we'll just need to get rid of this integral as well. So now we'll solve for this part, and as we know that the integral of 1 over u will be ln u over 2, and since u equals to x squared plus 1, the result will be this 1 over 2 of integral of 1 over u du will be equal to ln x squared plus 1 over 2. Now this 2 came actually from here. We also have it in here. So for now, the final result will be this. And what we see here is that c, the constant. So we should not forget it. So the last step, what we're doing here is basically putting everything into the function. So we already found this part, and by putting what we've found so far, it will be negative a times ln of x squared plus 1 over 2 plus b minus a arctangent squared of x over 2 and plus ax times the arctangent of x. So it will be the integral of x squared plus b minus arctangents times arctangents of x over x squared plus 1 dx will be b minus a times the arctangents of square root of x over 2 minus this part plus this. Also we have c here, so we'll just make it into the one denominator, which is 2, and just rewrite the other part. Also we have a c here. So this will be the end of this very long function. So that's it.